last week we did the power rule was the big one, the power rule and the constant multiple rule, right? Those were two of the big ones. So really at the end of for derivatives, there's a power rule, constant multiple rule, quotient rule, product rule, which we're going to do those two today, and then there's one called the chain rule. Those are really the five big rules. Okay. After today, we're going to have the bulk of these things taken care of. Okay. So first off, product rule. Product rule says the product of two differentiable f and g is itself differentiable. Moreover, the derivative of fg is the first function times the derivative of the second, plus the second function times the derivative of the first. Now, if you look at that, it looks really confusing, right? F of x times g prime of x plus g of x times f prime of x. See down at the bottom I put way to remember? This is how I learned it. This is how I remember it to this day. If you memorize that phrase, 1d2 plus 2d1. That means first one times the derivative of the second plus the second one times the derivative of the first. Okay? 1d2 plus 2d1. You remember that, you're going to be just fine. That's the product rule. All right, you could also use it for more than one term. So if you have like 3 sets of parentheses, for instance, you could apply it to that as well, just in a series, kind of like foiling. All right, so here we go. Let's use it for a couple of them. So first one, h of x equals 3x minus 2x squared, 5 plus 4x. So this is our first term here. This is our second term. Okay, first term, second term. 1 second. All right, so we had our two terms there identified. Okay, the first one's first set of parentheses, second one's second set of parentheses. Pretty straightforward in a scenario like this, where they're already in the parentheses. So I want 1d2 plus 2d1. So h prime of x is going to be 1 is right here. So 1 is 3x minus 2x squared. d2. So what's the derivative of the second one here? 5 plus 4x. What's the derivative of that? Just 4. Yep. Okay. And then plus 2, which is 5 plus 4x, d1. What's the derivative of the first one? You switched them around. 3 minus 4x. Right? You switched your powers, um, your signs around. All right, so this is 1. This is derivative of 2. This is 2. This is the derivative of 1. Okay? So from there, let's go ahead and simplify. So I'm going to multiply through. First one, you get 12x minus 8x squared. Plus, over here I get a FOIL, 15 minus 20x plus 12x minus 16x squared. All right, combine like terms. Negative 24x squared plus 4x plus 15. Now, a big thing with the product rule and the quotient rule is after you do the differentiation, you're going to have to simplify. Okay, that's a pretty common thing. A lot of these, because like here, technically, this is the derivative. Technically, right? But that looks like nothing we can use. Okay, so in this case, that's why we had to, after we differentiated it, then we had to simplify the things. So I just put it in the simplest form. You guys all right with that? All right, let's try another one. You guys want to try this one? Okay. I got some more later. I'll let you try them later. All right. That's fine. So sine, just let's flash back real quick, is right here. Derivative of sine is cosine, derivative of cosine is negative sine. Okay. Now the other thing you can do, I've seen some people do this, I don't love it, but I've seen other people come over here and say, all right, D1 is this, D2 is this. You know what I mean? Just kind of write it off to the side what the derivative is. You can do that if you find it easier. We can do it here just for the sake of this problem, and so we did it both ways. So here's the first term, here's the second term. So what's the derivative of 3x squared? 6x. What's the derivative of sine of x? Cosine x, we just said that. All right, so here we go. Y prime equals 1 3x squared. D2 is cosine x plus 2, which is sine of x, D1, 6x. All right, now simplify a little bit. Just be careful here, especially on the second one. I just dropped the parentheses here. Now the second one, this is not sine of x times 6x, where the x's are going to multiply. You don't get 6x squared. Remember, for sine, that x, sine, cosine, tangent, that x's is kind of special. Everything else goes out front as coefficients. So this would be 6x sine of x. Okay. The only other thing you could do to simplify, you could factor out 3x out of both of these guys, but it's really not a lot of point to it. I mean, I can write it here. X cosine x plus sine x. So either one of these two would be acceptable answers. Questions? All right. Let's do another one. Like I said, I'll give you guys a couple at the end to try. So right here. Y equals 2x cosine x minus 2 sine x. Now, in this one here, we're really going to apply two things. Right? If I look at the first one, here I have product rule, right? 2x and cosine x. Those are two different things I'm multiplying together. Here, though, it's just like the constant multiple rule, right? Because negative 2 is a constant. There's no x with it, so because of that, it's your coefficient. It's constant. All right, so we're going to apply the chain rule, not the chain rule, the product rule.
Call me Ernest, please report to the office. Call me Ernest, please report to the office.
We're apply the product rule to the first one, constant multiple rule to the second one. So here, here's 1, here's 2. So y prime is going to be 1 d2. Derivative of cosine x is going to be sine of x plus 2 d1. And then I just have the constant multiple, so it stays the same with the 2. Sine of x goes to cosine of x. Then I just simplify. I mean, I'm going to have 2x, negative 2x sine of x plus 2 cosine of x minus 2 cosine of x. So those cancel out, leaving me with just negative 2x sine of x. All right. Not too crazy yet, is it? I mean, the differentiation is still, I think, pretty simple. You just have to plug it in that formula. 1d2 plus 2d1. Okay. 1d2 plus 2d1. I would memorize that. Okay. All right. Let's keep moving. Quotient rule. So quotient rule is for things that are written in fraction form. Now, one big thing to consider, you'll see this here in a minute, Just because you see a fraction doesn't mean every fraction is a quotient rule. Okay, sometimes it's easier without knowing the quotient rule. We'll look at those in a couple minutes. But for now, let's look at the quotient rule and try a couple of this. So the quotient of two differentiable function f and g is itself differentiable at all values of x for which g of x is not 0. Moreover, the derivative of f over g is given by the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the square of the denominator. Again, a lot of junk, right? Here's how to remember it. Low d high minus high d low over the square of what's below. Okay, that phrase is how I was taught. That's how to memorize it. So low, that's your bottom, times the derivative of the top, minus the top times the derivative of the bottom, over square in the bottom. Okay, low d high minus high d low over the square of what's below. There's two little phrases. Those will save your life, I promise. All right, so right here we have the quotient rule. Y equals 5x minus 2 over x squared plus 1. So let's start. Y prime is going to be so I have high or low d high. So low is x squared plus 1. D high, what's the derivative of 5x minus 2? 5. Minus high, which is 5x minus 2. D low, what's the derivative of x squared plus 1? Two x. Bring the power in front, subtract 1 from the power. Okay, so low d high minus high d low, and then the square of what's below. X squared plus 1, 20 squared. All right, so there, we differentiated it. Simplify. So on top, I'm going to have little distribution, so 5x squared plus 5. Over here, I'll leave it negative alone and distribute first. So 10x squared minus 4x. And then I would drop that, and this would become a negative. Negative, this becomes a plus. And I'm just leaving this bottom the same. I'm not expanding it. It's factored form, so we're good there. What, on the bottom? X squared plus 1. What, down here? You can't distribute that. You have to FOIL that one. So you'd end up with x to the 4th. Then you have to try to factor out a little bit. That's what, in this case, the fact that it's really in factored form, that's why I just let it be. Okay. All right, and then below, now if that was multiplication in between instead of addition, I could cancel. All right, and then let's combine the tops. So I'm looking at negative 5x squared plus 4x plus 5 all over x squared minus or plus 1, 20 squared. That looks like it to me. I don't think that top's going to factor to anything that can cancel. All right, questions? It's not horrible, is it? Here? Negative 10 and positive 5. It's going to be negative 5. Combine like terms. Okay. All right. So, next one. You good, Hunter? All right. Sometimes you got to rewrite it a little bit before you can differentiate it. All right. So what we're going to do here, we're going to find the equation of the tangent line to the graph of f of x at negative 1, 1. So what do we have to do? Find the derivative, plug it in, right? So for this guy here, I don't like that there's a fraction and a fraction. You agree with me? It's just not pretty. All right, so we need to find some way to get that out of there. So you really can multiply the top by the common denominator, right? Which would be x. Find the common denominator, simplify it, and that kind of stuff. So I'm going to multiply the top by x, but to do it to the top, I got to do it to the bottom as well. Okay, so then if I multiply everything by x, I'll have 3 times x for the first one. Second one, I'm going to have negative 1x over x, which is just going to be 1. Okay, and then the bottom, I distribute that x through, I get x squared plus 5x. Now that guy looks a little easier to deal with, doesn't it? The fact that there's no more fractions. All right, so f prime of x. So low, x squared plus 5x, d high, what's the derivative of 3x minus 1? 3. Minus high, 3x minus 1, d low, what is the derivative of x squared plus 5x? 2x plus 5, good. Over x squared plus 5x. All right, so let's do some simplification. So on top, I'm looking at 3x squared plus 15x minus 6x squared plus 13x minus 5. I went ahead and fold that and then just simplified that a little bit. All there was some x's to combine. So I would have had 15x and negative 2x, which is going to give me 13x. Is that right with that? All right, and then all of that over x squared plus 5x 20 squared. Okay, last step, I distribute that negative sign through to everything on the right, on the top. Then combine like terms, I'm going to get negative 3x squared plus 2x plus 5 all over x squared plus 5x 20 squared. Okay, now what does it ask me for? There's my derivative. It asked me for the equation of the tangent line to the graph at negative 1, 1, right? So right there is my function. Okay, I have the point that I want this at, so what do I need to plug in for x then? Negative 1. Okay, so I need to find f prime at negative 1, and that's going to be my slope at that point, right? So I'm looking at negative 3 times negative 1 squared plus 2 times negative 1 plus 5 all over negative 1 squared plus 5 times negative 1, and then the whole thing squared. All right? All right, so that negative 1 here turns positive, so I have negative 3 minus 2 plus 5. On the bottom, work inside out, so that's going to turn positive 1. Positive 1 plus negative 5 is going to be negative 4. All right, so then on top, I'm going to have negative 3 and negative 2. It's negative 5 plus 5 is 0 over positive 16. So what's my slope there? 0, isn't it? Okay, my slope's going to be 0. So then if I want an equation of the tangent line to the graph there, well, my slope is 0, so I'm just going to have y equals 1, right? Questions? So it'd be a horizontal line. Okay. Constant multiple rule for some quotients. So remember I said just because there's a fraction in it doesn't mean they're all quotient rules. Okay, this is where you're going to see that. So what we're going to do, I'm going to give you a couple and we're going to rewrite them and use the constant multiple instead of doing the whole quotient rule. Okay. I think the big thing you'll see too is there's no x's on the bottom of these except for a couple. So let's use y equals x squared plus 3x over 6. Okay. I think you can see right now there's no x's on the bottom, right? So as soon as there's no x's on the bottom, yeah, you know what? Let's see if we can use something other than the quotient rule. That's a pretty good giveaway. So I'm going to rewrite this guy as 1/6 x squared plus 3x. So now all of a sudden I no longer have quotient rule even available, do I? No. All right, so I'm going to differentiate that. So y prime is going to be 1/6. Remember, it just tags along, and you differentiate what's inside. So what's the derivative of x squared plus 3x? Good. 2x plus 3. So then that's just going to be, I'll simplify this back, 2x plus 3 over 6. Done. Not horrible, is it?
I would have failed calc and not been allowed to take this one.
Try that one, guys. Rewrite it, differentiate it. Good? Good? What'd you get? What'd you get? I want to know what you had first.
What'd you get? I got 20x cubed over 8. That's what I got. That's not what you want.
You just didn't simplify it far enough. 20 over 8. Be what? 5 halves?
Yeah.
Yeah, you're good. Yep. So you can rewrite this as 5/8 x to the 4th, right?
I did 1/8 and just kept the 5 in parentheses.
That works too. All right, so I just took out the 5/8. All right, so then I had 5/8 times the derivative of 4x, which would be 4x to the 3rd, right? All right, then multiply, and I get 20x to the 3rd over 8, which is going to be 5 halves. 5x to the 3rd over, 2. Okay. Let's look at a couple more here like this. Number 3. I'll do the first one. You guys can do then the second one. Okay. They'll be similar, not exact. But so y equals -3, 3x minus 2x squared over 7x. This one's a little bit tricky because it looks like it should be a quotient rule, right? looks like you should probably maybe multiply the top through and then apply the quotient rule. But sometimes you can rewrite these and make them even easier on yourself. All right, so let's rewrite this guy, and I'm going to pull out the -3, and I'm going to pull out the 7. Okay, now that's leaving me then with 3x minus 2x squared over x. Now what do you see in that parentheses? See anything? I can make this simpler. X on the bottom, and I have x's on both the terms up top, right? So I can cancel an x out, yeah. So it's going to be -3 over 7 times 3 minus 2x. That feels a lot better to try to differentiate now. Now, y prime is going to be the number I pulled out. What's the derivative of 3 minus 2x? -2. All right, so this is just going to be what then? Positive 6 over 7. There you go. All right, last one. This one's on you guys.
Yeah, this is so much better.
Isn't that kind of fun too? It's kind of like a game. I think it's like a game.
I don't know about fun, but it's easy.
All right, so here you go. Don't forget, an x on the bottom you can pull to the top, and then it does what to the exponent. There you go. You can factor out the fraction, and then you take the x back to the top, and it'll be a -2 power. That's what I would do for the rewrite. You can answer?
Yeah.
What'd you get?
-18x over 5.
Real close. What'd you get, Hunter?
I got the same thing. I got -x squared, then get the derivative, and then multiply by -18 over 5.
Okay. All you guys messed up was the x. All right, so I factored this out, right? 9/5 x to the -2. You guys both got that? Okay, so then y prime is going to be 9/5. What's the derivative of x to the -2? -2 x to the subtract 1, right? Put the power out front, subtract 1. So that becomes -3. That's what you guys both missed right there. Okay, so then when I multiply this through, I get -18 x to the -3 over 5. Now the problem is the negative exponent, right? So I just take it at the bottom. So -18 over 5x to the third. Questions? Let's do this proof real quick. So remember, here's the derivatives of trig functions. So derivative of tangent is going to be secant squared of x. All right, the first couple were easy. Sine, cosine, sine was cosine was negative sine. Okay, those ones are pretty easy. The rest of them aren't quite as easy. So tangent of x, derivative is the secant squared of x. Cotangent, negative cosecant squared of x. Secant of x is going to have derivative of secant of x, tangent of x, and cosecant of x equals negative cosecant x, cotangent x. All right, they're a little sloppier than just sine and cosine. You're mostly always going to see sine and cosine. I'm going to say 80% of the time, sine and cosine are going to be in the problems that you're trying to differentiate. All right, but sometimes you get something like a tangent a little bit. So let's do a little proof. Remember back when we did all that stuff where we justified both sides? This is why, partly. This is why we're getting to the point here where we can rewrite and we can use these to justify what we're doing. All right, so remember that the tangent of x is equal to sine of x over cosine of x. Remember that one? Okay. I'm not going to make you do proofs, but I want to show you this proof, show you where this comes from. Why does the tangent of x have a derivative of the secant squared of x, okay? So let's apply the quotient rule to that right there. All right, so dy dx, derivative with respect to x, of tangent of x, and I am going to use this for tangent of x. I'm going to substitute tangent of x with sine of x over cosine of x. Well, I have low d high, low is cosine of x, d high, derivative of sine of x is cosine of x, minus high sine of x over d low. All right, the derivative of cosine of x is going to be the negative sine of x over the square of what's below. All right, do a little simplification. So cosine squared of x plus sine squared of x over cosine squared of x. Now, cosine squared of x plus sine of x, sine squared of x, what's that equal to? Remember that one? It's Pythagorean identity. Good, it's equal to 1. All right, so cosine squared plus sine squared is equal to 1. And it's all over the cosine squared of x. Well, 1 over the cosine squared of x was equal to, sure you remember this, secant squared of x.
Oh, yeah. Feels just like yesterday.
So right there, what did this do? Well, first off, it justified the derivative of the tangent, and it also justified the quotient rule. All right, so we just justified two things with one proof. Questions? All right, we'll stop there. We'll pick this up and finish this on Tuesday or Thursday. And remember, on Thursday, I'm going to give you that worksheet that'll do for a graded assignment. All right.